Hello everyone. Welcome to the first video of this series on containerizing blueprism application using Docker. I'm Shankar and I'll be your host for this series. Most of you might be aware of the containers and their benefits. But if you are not, then just to let you know that the containers are the next big thing that will change the technology market. It brings a plethora of advantages over conventional VMs. In this video series, we'll deep dive to see how we can leverage the container technology in RPA using blueprism. I think it makes sense to understand the merits of the approach first before we even look into those technical details on how to build them. That is exactly why I have kept the demos at the first. With Docker hosted in cloud, you can think of many different types of architectures, but each will provide you with some benefits and some limitations. In today's session, I'll demonstrate one of them and then we'll test the performance using a notepad application that I have created for this purpose. The architecture looks like this. I have created two Windows 2019 VMs in Azure, which will act as my Docker hosts and will run my blueprism server containers. I'm using Azure SQL Server to host my blueprism database. And for load balancing purpose, I am using the default Azure load balancer. Apart from this, I have one Windows 10 machine with blueprism client installed, and this will connect to the load balancer to use blueprism server services. So let's see the system in action. The image required for this demo has been created and uploaded to my Docker Hub account. I have downloaded the images in my Docker hosts as well to avoid downloading the same during this demo. The blueprism server image that I'm using for this demo is built on top of long-term servicing channel, or in short LTSC version 2019 of Windows Server Core. Docker in Windows has some OS dependencies. So if you're planning to use Windows 10 as OS of your Docker host, then this blueprism image might not work, and in that case all you need to do is to build an image with the right version of Windows Server Core which is supported to run on Windows 10 Docker machine. So here are my VMs, two Docker hosts running on top of Windows 2019 machine and a Windows 10 blueprism client machine. I'm connected to them via remote desktop. Let's look into the Docker machines first. In each of these Docker hosts, I have started blueprism server as a service with one replica. If we dig in further, we can see the following details related to BP server service. It shows only one instance is in running state and the service is published on port 8199 of the Docker host. Rest all instances are in shutdown state. This is because during my testing, I shut down the Docker host and that caused the earlier instance to exit. So till the time the service is in running state, the system will make sure to keep the requested number of instances up and running even if they are crashed or exited for various reasons. And it will make sure of the availability of the services on the published port. Let us look at the second Docker host as well. I have configured this server the same way as the first one. And you will see that same BP server service is running in this system as well. And if you dig in further, you will see that one instance is only in running state. Finally, let us look into the client side. So I have created one demo application for our testing purpose. It's a notepad application, and this client machine is gonna connect to the load balancer to connect to the BP server to execute this application. Before we proceed with the actual demo, let's have a quick look of the load balancer. You can see that I'm using an internal load balancer and the IP is 10.0.1.15. This is to route the traffic coming from the blueprism client to the backend servers. To get the more details about the servers, we can have to look into backend pools. So my backend pool has two VM servers, VM1 and VM2, the same one where we hosted our Docker. Let's go back to the client now, and we'll see the connection parameter first, and then we'll log in and start our demo. So as you can see, the connection parameter, basically I'm pointing to the load balancer and the port is 8199. So we'll now log into this blueprism client using the admin account. So we are connected to the blueprism server now using the load balancer, and the system is ready for the demo now. Let's wait for the BP client to come online. So it's gonna take few seconds to come online. I think it's online now, and we'll assign the notepad application that we created for this testing purpose. Okay, it is assigned. Let us start the process first. Okay, it is in running condition. So in a few seconds, you will see the notepad screen and it is showing the time it has taken from the previous step. So now for this demo purpose, what we are going to do is that we are not gonna let it run freely, rather interrupt the connection between the blueprism client and the server. So here what we are doing is that we are going to stop the BP server instance that will actually break the connection between the client and the server. You see that the notepad application is not updating anymore. Uh, so this is because it lost the connection. Now it is again back online because of the load balancing feature. The load balancer helped it to connect to the second server. So this is our second server. We are gonna do the same exercise like stopping the container and make it fall back to the primary one. Only difference that we are gonna stop the primary as well, so that none of the BP servers will be available, and we wanted to see the behavior of the system when both the servers are down. Because of the service feature, it is supposed to bring up, and we wanted to see how the application behaves in that kind of situation. Now you see both the servers are down, so there is no available server, so the load balancer has no way to route the traffic. So the application is stopped and the notepad is not updating. But as you are aware that Docker always monitors the number of replicas that you have requested, and if it sees that the number of replicas went below the requested number, so it will bring up automatically. So by that rule, we are supposed to see new instances of blueprism server are started on those Docker hosts, and very soon this server is expected to get connected. I think it's already connected, as I can see that the contents are getting updated now. So basically within few seconds our client is able to connect to the servers. Please understand one thing, we actually took the servers down in a very drastic manner. We simply shut down or kill the instances, which is not supposed to happen in a production environment. But obviously if it happens for some reason, then also you see how quickly the system restore it back without any impact. Moreover that the client is able to connect back and it is able to execute the things in a very proper manner. And that is the beauty of this architecture. So if you scroll down, you'll understand that for the first transition, we took only 11 seconds, and the second transition, I think it is 4 seconds. Yeah. So So which actually indicates that it's not much time it took for the system to connect back. Also, I like to remind you one thing. Blue Prism client takes a certain amount of time to connect back to the server if there is a loss in connection. If you tune that parameter, you might get a better performance with this kind of architecture. I hope I'm able to make my points clear, and I hope you understand the merits of this architecture. So that's it for today, I think, and I'll come back to you with a new architecture with a more complex setup. Till then, thank you so very much for joining this demo. I hope you get some good insight out of this. So stay tuned and we'll come back with more such videos.